Here we've got a little bit of practicing with oxidation numbers and reduction and or reducing and oxidizing agents. So let's go ahead and answer the questions. Determine the oxidizing agent and the reducing agent in each reaction below. Until you start recognizing them quickly, which can happen, it's best to assign the oxidation number of every species in the reaction first and then go from there. So here, when I look at H2S, H really wants to be +1. There's two of them, so the sulfur must be -2. Nitrate, I've got a nitrogen and an oxygen. Oxygen really wants to be -2. There's three of them. That means an overall -6 charge from the oxygen alone. The species, though, has a -1 charge, which means nitrogen must be +5 to counteract the negatives of the oxygen, leaving me with a -1 charge. Here, my hydrogen is just +1. It's a single species with a plus charge. It's +1. My sulfur here, 0. That's the only thing listed, so it's going to be 0. My NO, oxygen is more electronegative. I know you guys haven't learned that quite yet, but the way to tell is it's listed second, so it's going to get its way. Nitrogen becomes -2, which means nitrogen has to become +2. And then water. Water always has the same format, oxygen -2 and hydrogen at +1. So I look at this and I say, okay, what changed? I've got hydrogen at +1, +1, +1. Well, it didn't change. I've got sulfur at -2, sulfur at 0. Oh, that one changed. Okay. I've got nitrogen at +5, nitrogen at +2. That one changed. I've got oxygen at -2, -2, -2. That did not change. So my sulfur went from -2 to 0. It lost 2 electrons, meaning that the sulfur was oxidized, because oxidation is lost, meaning it is the reducing agent. When I look at the nitrogen, nitrogen went from +5 to +2, meaning it gained 3 electrons. And again, they are balanced when you actually look at the balanced reaction. So that's why the number of electrons don't have to match. Nitrogen gained, gaining is reduction. Sorry. Which means it's the oxidizing agent. Let's look at the next reaction. I've got manganese and oxygen. The oxygen is -2. There's two of them, giving me an overall -4. So the manganese must be +4. HBr, hydrogen really wants to be +1. Bromine's quite happy being -1, so they're +1, -1. Manganese bromide. Bromide is going to stay -1. The manganese, because I have two bromides at -1 each, the manganese has turned to +2. Here I've got Br2, which is its most stable states. The bromine moved to a 0 charge. And then I have a hydrogen and oxygen, -2 and +1. So manganese +4 +2, that something definitely changed there. And I forget to do it. Let's just intentionally put the line for the reactant to product in here, because otherwise it's kind of confusing. Manganese, definitely something happened. Hydrogen +1 +1, nothing happened there. Oxygen -2 -2, nothing happened there. Bromide -1 -1, looks like nothing happened, but then I see this bromide here at 0. So one bromide did do, some of it stayed the same oxidation number, but some of it did change as well. So my manganese went from +4 to +2. It gained 2 electrons, which means it was reduced, and it's my oxidizing agent. My bromide went from -1 to 0, meaning it lost an electron. It was oxidized, and it's the reducing agent. Again, notice that your oxidizing reducing agents are always reactants. It's not your products doing this, it's your reactants doing this. Okay, and our other example, determine the oxidation number of I should say the red, but let's just do of each. Determine the oxidation number of each element in each of the following compounds. So dihydrogen phosphate. Dihydrogen means two hydrogen, phosphate, PO4. I have two hydrogens, which each give a +1 charge, so dihydrogen phosphate is H2PO4. It's easiest to kind of think about this split up. Each hydrogen will give a +1 charge, leaving that phosphate behind, PO4 3 minus, which means phosphorus and oxygen. Oxygen wants to be a -2. There's 4 of them, so that is a -8 charge overall, which means the phosphate must be a +5 so that it can form this charge. If you're ever unsure, add it up. You have 2 hydrogens at +1 each. You have a phosphate at +5, and then you have 4 oxygens at -2 each, and this has to equal -1. 2 plus 5 minus 8 is equal to -1. 7 minus 8 equals -1. Yep, you added it up right. Sulfite, SO3 2 minus. Again, oxygen really wants to be -2. There's 3 of them, so that gives me an overall -6. But I need the compound to be -2 overall, so this must be a +4. Again, if you're ever unsure, you have 1 sulfur at a +4 charge, adding it to 3 oxygens at -2 charge each, and you need a -2 charge overall. So 4 minus 6 equals -2. Yes, that is correct. And our last one, dinitrogen, so N2, tetroxide, O4. Oxygen really wants to be -2. There's 4 of them, so it needs to be a -8 overall. The 2 nitrogens have to charge balance that, so 2 nitrogens have to be +8, which means each nitrogen has to be a +4 charge. Again, check your answer. 2 times +4 minus 4 times, or +4 times -2 equals 0. 8 minus 8 equals 0. You have the right answer.